Hello everyone and welcome to the Git and GitHub workshop. I'm Junrong and today with me we have Yue and Steve. If you need any help today, you can ping us on Discord using these handles here. So you may have heard of or even used Git or GitHub before, whether in the Building Blocks Amazing Race or any other Building Blocks workshops. But have you actually wondered what happens when you fork a repository? What's a repository anyway? Today, we are going to answer those questions, as well as take a much deeper look at Git and GitHub. Firstly, we have one important thing to note. Git is not the same as GitHub, although they are usually used together. They are distinct tools and serve very different purposes. Let's look at each of them in detail. So Git is a version control system. In English, Git records changes to files and allows you to revert to specific versions later. Think of it as a version history for code, much like Google Slides tracks this presentation and allows you to go back to previous versions of this presentation. So before Git was invented, developers had to resort to very ridiculous forms of version control, like adding the final suffix to files, or even adding underscores to the ends of path names. Git solves these problems by storing version history for you. Next, what's GitHub? So GitHub is a code hosting service for Git. It stores the official history of a project, or in the GitHub terminology, repository, in the cloud. GitHub is a centralized service, while Git is distributed. Think of it as an email provider like Outlook, while Git is the email client on your devices. We will be looking through this analogy in more detail in a while. So because of its centralized nature, Git also acts as a backup for your code. Before GitHub, hardware failure could mean the complete destruction of all your code if you didn't have any backups elsewhere. In the past, people that were working on big projects actually emailed their code around. As you can imagine, this is incredibly messy, and tracking the latest version of a project is incredibly complicated as well, leading to many conflicts. So GitHub solved this problem by creating a centralized and official history of a project. Let's get started. Hopefully you should already have a GitHub account, and you can use the same one that you used for the Building Blocks Amazing Race. There's no need to install anything on your devices today, as we'll be using Gitpod for everything. This repository is on GitHub, and you can access it using this URL here. So GitHub can show us some very useful information about this repository or project, such as the owner, which is me, the repository name, which is Git Workshop, the description, which sums up the whole purpose of this project in one line, the files, as well as the README file. This README file is particularly important as it provides information about what the project does and how to set it up. So the first step of contributing to a project on GitHub is forking it. When you fork a repository on GitHub, an identical copy of the repository is created just for you. You can make changes to the code of the fork without affecting the original project. This is an incredibly powerful feature because it allows many people to work on the same project at the same time without conflicting with each other. So this development actually contributed to an increase in productivity in software development. And of course, the changes in each fork can be subsequently merged into the original repository using pull requests, which we'll talk about in detail later. So go ahead and fork the repository by clicking this button. You should be able to see this button when you open the repository with the link that I've just sent. So once you've opened Gitpod, you should see something like this. This picture is a bit of an older picture, so you'll probably see more files here. There are three parts of Gitpod that we'll be using today, which is the File Explorer, which you can view all the files and open them. The editor, where you can edit files. And most importantly, the terminal, where you will be running all the Git commands today. We'll be doing most of our work in the terminal. Yeah. So, like I said, this is a bit of an old photo. But you'll notice that the files here are exactly identical to those on GitHub. So you might be wondering, how does Gitpod even do this? So Gitpod does this using a process called cloning. It's got absolutely nothing to do with biology, so don't be worried. It's just a fancy term for downloading files from GitHub and setting up a bidirectional link between the two. So this link is incredibly important because it allows you to easily sync changes between your local environment and GitHub, which is the remote environment. So to ease development, Gitpod does this process automatically for you. If you would like to work on this project, if you would like to work on any GitHub project on your computer, you can use this command, which is git clone github.com/owner/repository name. So now we have hopefully all set up our environments. Steve will talk about basic Git commands.
Hello, I'm Steve, and yeah, like what Tino said, I'll go through the basic Git commands, including add, commit, stuff like that. All right, before we get started, okay, yeah, that's the right slide. Before we get started, I would like to clarify that when I say created, I mean create a new file, like how you would do it, like create a new text file, how you would do it normally. But when I say added, I mean add the file to Git. So what does adding mean? Next slide, please. All right. So files can be added to Git, in which case they're then called staged. And only changes made to staged files, aka stage changes, and new files added, aka staged files, will be recorded during a commit. New files have to be added and committed once for it to be automatically tracked. And by that I mean Git will know the changes that have occurred to the file since the last commit. Obviously, if there are no previous commits, there's no way that Git will be able to know that the file has changed. So how do we add files? There are two ways of doing this. The first is to add all files and changes, also like staging them, obviously. By adding is the same thing as staging. So that you do that with the suffix -all. Like I would write it as -a, -A. It's case sensitive, but it's the same thing. It's just an alias. You can also add individual files through git add and then the file name. All right, next. Okay, there we go. So there's also git reset, which is just the opposite of add. So you don't permanently add anything. All right, next slide. And these slides will be made available to you. This slide right here is basically a cheat sheet for all of the possible statuses of a file in a Git repository. Has it been sent? Jerome, can you send the slides to the chat real quick? Okay. Let's continue. Next slide, please. So the next command is git commit. How you would use this, you must always have the -m in there. Why I wouldn't go into further elaboration right now, but after the -m, you would put your commit message in quotes. Now, writing a commit message is an art because you have to succinctly describe what changes have been made, and this is an absolutely compulsory part of Git. You cannot omit this. So quite a good commit message would be remove deprecated date picker from date selection. The commit message, by convention, should always grammatically follow the phrase this commit will. So for example, here I can say this, and not yet, this commit will remove deprecated date picker from date selection, and that sentence makes perfect sense. All right, next slide. So what is staging exactly? Staging is a preparatory area which you would put your new and changed files in before committing it. This allows you to customize which files or changes to commit. In this example, we have two files. Two files. File 1, which is a tracked file but has been edited, and file 2, which is a new and untracked file. All changes done and new files added have to be new files created have to be manually added to the staging area. So here I will need to type the command git add -a, and this will stage both files. Now the next stage happens, where the files are committed. Think of a commit like taking a photograph of the stage. Once you take that photograph, the current status of the stage has been permanently stored. Once the photograph has been taken, the files are considered committed. File 2 is no longer considered untracked, and file 1 is no longer considered edited. Therefore, they will both appear blue. The stage is cleared and ready for the next time a file is staged. Okay, and you can keep tabs on what's happening with Git using the commands git status, which checks which files have been edited or added since the last commit. And you can also use the command git log, which allows you to check your commit history. This focuses your terminal into like the git log itself, and it took me a while, but you must press Q to exit the git log if you want to type other commands. And Hongyue will explain this in detail later. So right now, I'm going to do a demo on this. Just create a new file, untitled.txt, a very descriptive title right there. And I can just git add untitled.txt. And I want to check whether or not it's been added, so I do git status. And you can see it says there's a new file. If I do git reset untitled.txt. By the way, you can press the up arrow to go back to previous commands while you're in the terminal. So we go back to git status. And as you can see, it says the file is untracked because I reset the change. Anyways, let's add that. You can also add it through -a, obviously. And git status, it's there again. And okay, this is the main branch from General's. This is not a forked version of the workshop. But anyways, I'll just commit it. Your changes will not appear like inside Zero's repository, so you don't have to worry about that. So git command, let's see. I just write add untitled.txt, and then that's finished. If I go git status, there's nothing to commit because the stage has been cleared. So then we can go to git log, which checks all the previous commits. And as you can see here, this commit right here, author Blue Steve, date is right now, and the commit message will be shown here. Okay, I think you guys should be ready to do some missions. Please navigate back to general slides. Just go back to the screen. Okay. So there are two more commands that are essential for Git. You have git push, which uploads the changes. So git push would upload the changes to a remote repository. So in this case, from git pod to GitHub, and git pull does the opposite, and it downloads the changes from GitHub. This is basically like uploading a file or downloading a file from Google Drive. And how you would do it, you just type git push, like that's it, 2 words into the command line, into the terminal, and you will be able to push it.
Okay. Yeah. So by the way, if you are really comfortable with the basic Git commands, you can switch to my stream, and then we can try out the missions. And then yeah, if you're already done with the missions, like the fifth mission. You can look at the other missions in the slides.
Okay, for those of you who are struggling with mission 2.1, I'll share my screen and I'll go through all of it. So here we have file 1, and you will just edit the file. Okay, you see the white dot here, and then you would save the file, press Ctrl S to save the file, the white dot disappears. Git status says that file1.txt has been modified. You won't see the new file here because I did a bit different, but what you want to see is modify file1.txt. Yeah, file, click on file and save file also works, but it's just Ctrl S. And then besides modifying file 1, both file 1 and file 2 should be modified. And then you add all the files, then verification should work. The point of typing git status twice is for you to see that because file2.exe is not currently, has never been staged before, has never been inside a commit before, it's a brand new file, no matter how much you change it, the git status will always be the same because it's untracked. So what is Git in relation to GitHub? You can consider Git as a local email client, for example, Outlook, while GitHub is like the Microsoft server. Drafting and editing emails is like committing to Git, which is done locally, while sending and receiving emails is like pushing and pulling from GitHub respectively. An email travels to the server and back, just like how our code gets sent to GitHub servers and back. Furthermore, just like how there are multiple email providers like Gmail and Microsoft, there are many servers which you can push your changes to. GitHub is simply by far the most prominent and popular one. In fact, you can even make your own Git server if you choose, if you have a server lying around. Right, so the next part will involve branches, which is more advanced Git, which my friend Hongyo will go into.
Yeah, so I'll be talking about branches. Okay, so here's an important analogy for Git. So let's compare Git to a tree. You'll see a lot of tree analogies in the naming and the theming of Git because, I don't know, the creators of Git probably like trees. So in this analogy, let's just call our working copy a tree trunk. As the name branch implies, it's like making another branch on our hypothetical tree here. So if you make any changes on one branch, it won't affect any other branch. If even if you destroy a branch, it won't change other branches. So syntax wise, what you want to do is use git branch and then the name of your branch if you want to make a new branch. And if you want to change to look at a different branch, you can use git checkout. Okay, so there are some of the uses of branches would be, firstly, you can use it to add new features to things without having to affect master, and then you can merge them when they are stable and done. For example, in the diagram you can see here, there are different branches for different features like adding a calendar. Before the calendar is stable, you wouldn't want your users to be able to see it. So you can use these branches to hold such in development changes and then merge them in later when you think that they're ready for the users to see. Sometimes another strategy used for branching is to have a master branch where you do your development work and you add any new features you need, and the stable branch which only has bug fixes that you've tested. And sometimes there'll even be branches just for testing hot fixes and for supporting older and unsupported features. This is used in quite a lot of open source projects, so now you know what it means when you see things with a development branch and a stable branch available for you. Okay, so now I'll talk about git merge. So an important thing in branches is if you want to merge, if you want to, once you're done with the features that you've been working on, you might want to merge them back into the main branch. So basically here, assuming you want to merge your features into the main branch, this is the syntax to do that. So merging is also quite important for when two people have different branches that have overlapping changes. So merging can get more complicated, but normally Git will be able to do it for you unless there's something that has gone very wrong in your collaboration. Please move. Yeah, okay. So I'll talk more about Git log. If you remember, Steve covered this a few slides ago. So basically what Git log does is it shows you a history of all the commits that you've made. Like, for example, if this is an example entry, which would be git log -ADOG in order to get a neat graph like this so you can see most of the changes that you've made for a while. From this, you'll be able to see the graph of the commits. And of course, your Git log might come up to be messy if you don't follow good commit merging practice. So do be careful. I'll explain another way in order to avoid having your Git log look very branched out like that. Okay, so here's an explanation of what all the things you see on Git log really mean. So I'm not sure if you can see it very clearly, but first you see some yellow gibberish letters at the start. What do these quote-unquote gibberish mean? It's actually the first few letters of your SHA1 hash. Basically, SHA1 is an algorithm that you can apply to any data. In this case, the data is the commit that you've made, and it will produce a string that should be unique in theory. It is possible to not be unique, but normally that won't happen. So using this hashes, as they call it, is a good way to make sure that you have a unique identifier for any commits. Normally Git log and GitHub will show only the first few characters of the SHA1 hash as it's quite long. So after that, you also see all the commit message on the commit in question that you're looking at. And remember, other people who clone your Git project will also be able to use Git log. So this is why you need to use good commit messages and not leave it messy. So at the top, on the first commit in the picture there, you will see something different. You see hit. That indicates the current position of the quote-unquote right hit, like the cursor sort of, where new commits are being put, where new commits go. So it's basically sort of like the end of a current branch, and any further commits will go at the head. And it will also show you which branches are up to date with the current head. Now I think we'll do a demonstration.
Okay, so basically we will just be demonstrating a few how you can use branches, and we'll also be demonstrating how we are going to merge these branches subsequently. Pay attention because it's really useful and it'll be needed in your mission in a while. So first, of course, we type a git status to find out what branch we're on. So you can see we are on branch master. So master is the main branch. It's the default branch for Git, and that's the branch we are going to merge our changes into in a while. The thing you want to do is type a git log to find out the commits that we have so far. So we are going to use git log all one line decorate and graph. So this shows it in a more pretty way. And a useful thing you can use to memorize this is git log a dog, which is ADOG, the first letter of all these options. So it will show a nice graph that it's not really a graph, it's more of a line right now because there's only one branch. So we can see all the commits here. Okay, let's create a new branch. So remember the syntax is git branch and then the branch name. In this case, we are going to use the branch name dev. So dev is quite a common branch name. It's usually the branch you merge into before the whole thing is merged into master. So dev is short for development and usually has all the latest changes. So if you remember just now, the syntax to change into a branch is git checkout. The syntax is git checkout and the branch name. So in this case, I'm going to type git checkout dev. And we will see here that we have successfully switched to branch dev. Yeah, that's great. So git status again. So now it says on branch dev, which is amazing. Okay, so now we can actually do our work. I'll just be creating a random new file, black.txt. Remember to save your changes using Ctrl S. Otherwise it wouldn't work, yeah. Okay, so I'm going to git add the changes, and then we should see it change from U to A. So this A means that the black.txt has been added. And I'll run git status again, and we will see that we have this black.txt is changes to be committed, which is great. It means it's been staged already. So now if we go to never mind. I forgot to commit. So to see your changes on the branch, you must commit your changes. And we have learned in the earlier missions, the command for that is git commit. So remember to have a descriptive commit message like create blair.txt. So now we should be able to see this graph here. We can see that this commit is on master, and a commit in front of it, which is this current commit, is on head, which is on dev. So as we have said just now, head is the so-called cursor of the git commit string. And it also points to dev, which means that these two reference the same commit, which is create blair.txt. So now the next step, assuming that we have completed this feature dev branch, the next step is to merge the changes back into master. So to do that, the first step is to always switch to the branch, the target branch, the branch that you want to merge into, not the other way around. So in this case, you want to merge into master. So I'll type git checkout. So now we are back into master, and you can see that the blair.txt is gone, which means that the changes just now only affect the dev branch. So to merge the dev branch, we type git merge dev, which is pretty straightforward. Okay, yeah. So remember, when you want to merge, you'll use git checkout to switch to the branch that you want to merge the stuff into. In this case, master. And then you git merge the branch you want to merge changes from, which in this case is dev. Yeah, is that clearer now? Okay. So as you can see, because there's no conflicts, Git is able to use the fast forward merge, and it will, if we show git log again, yeah, now we can see that this commit has already been added into master as well as dev.
Just to interrupt, notice how master and dev are both at the head, so they're both up to date with the create blair.txt. However, notice that origin, master, and head are both not there. So basically that means that at the remote one hosted on GitHub, it hasn't been merged. So to fix that, you have to push to the remote server.
Yes. So we'll basically be typing git push, but I won't type it now because that's your job in the mission. So I hope everyone is clear with this demonstration. Yeah, and we can try out the mission now. So remember to push the changes, otherwise we won't be able to see whether you have completed the task.
Alright, so here's another sort of related to branching command, but it's Git Rebase. Okay, basically Git Rebase is similar to Git merge, but in comparison with merge, where merge has an extra commit that moves all your previous commits from the other branch to this branch, Git Rebase changes the branch history itself to make it look like those commits were always there. At least that's one thing it can do. So there are a few things that Git Rebase can do. So basically, the pros of it are that it gives you a cleaner commit history and a git log, because instead of seeing merge commands everywhere, you'll just see it as one straight line, as if all the commits were there in the first place. And using Git Rebase, you can also do something called squashing of commits, where you can basically squash commits that don't look very nice on your repository, like the 10 plus attempts you took to fix a bug, and use it and make them disappear magically. Okay. So of course, Git Rebase has some cons as well. One of the cons is that it's very easy to mess up with Git Rebase and do something that you didn't want to do. Maybe erase a commit and continue, please. And as the second thing goes, if you use it on public branches that other people can edit, you're going to have quite a bad. The reason for this is because if the branch has multiple contributors, each contributor is going to be keeping their own history of the master origin branch. So if we use Git Rebase on that branch, it will cause duplication of commits, since the other contributors also have their own records of commits and you're adding another record on. This will make an even messier log than you expect. So basically, Git Rebase is quite useful, but you don't want to use it on any public branch. And so here's my recommendation about Git Rebase. It's very good if you know how to use it, exactly how to use it, and it can stop you from having messy situations. Basically, if you have no idea how to use Git Rebase and you don't know what it is, you don't strictly need to use it. If you get a commit history like this, you probably should learn to use it though. But you don't have to unless you really want people to know what it looks like. Okay, so the next part will be Jinrong talking again about publishing open source code.
The final and most important part of a project is publishing your code, so that everyone out there can enjoy, maybe, and use it, of course. So as Steve has mentioned, GitHub is one of the best places to do so, because it has a huge population and incredible popularity, such that it's actually become the de facto place to publish your code. In fact, as of now, there are over 40 million developers on GitHub, and that's a huge audience for potential users of your code. But there are some parts of your project that you don't want 40 million developers to see. For example, Discord bot tokens and other secret information. So fortunately, Git has you covered. The git ignore feature allows you to specify which files a git should not track. So this might be IDE configuration files, build files, your APKs, and also dependency folders. You most certainly don't want to publish your 1 GB node modules folder. And last but not least, you do not want to expose secrets like tokens, API keys, private keys, and signing keys. So you can use the git ignore file to tell Git what files you absolutely do not want to be tracked. So the important part is you must notice this dot in front of the name. If you do miss the dot, the git ignore will not work. So let's look through an example of the git ignore file. Just like Python, you can have comments using the hash symbol. So the git ignore file can get quite complicated. So some comments are necessary. And the files to be ignored are each placed on its own line. If you put multiple files on one line, it wouldn't work properly. So let me, there's also a negation, although this is a rarely used feature. So the exclamation mark in front of the file or directory name means Git should track this folder. So for example, the exclamation mark src, it tells Git that it should track the source folder. Okay, so now for a quick demonstration again. If the target file that we want to ignore is the secret.txt file, so it's incredibly simple to ignore it. I just need to type secret.txt. Oh right, I forgot to type git status. Okay, so we can see here that the secret.txt is an untracked file. And once I save this git ignore, it will no longer show the secret.txt file, which means that we have told Git never track the secret.txt file. So now I can type whatever secrets I want in here, and it will never be published to GitHub. So remember just now there was the U symbol here. Now the U symbol is gone. And Git actively prevents you from adding the secret file to Git. So if I type git add secret.txt, there will actually be a warning telling me that it's been git ignored, and that's probably something I shouldn't be doing. Yeah, so that's it for this demonstration. We can now look at the next mission. So this mission is quite special because you need to run a setup file. So essentially, you just need to type setup tree, /setup tree.sh, and you automatically create this super secret.txt file, which includes a Discord bot token and database passwords. So obviously, you don't want this super secret.txt file to be leaked. So the mission is to create a git ignore file and tell Git to ignore the super secret.txt file. So as usual, to verify, you can run the verification script, which is /verify3.sh. Once you're done, you can commit and push the changes, and we can see it on our site. We are going to talk about pull requests. So remember that I said forks allow for parallel development. So the pull requests allow forks to be merged into the original repository. So the pull requests are actually an integral part of open source because they allow everyone to propose changes to the repository. And project owners can discuss and review changes and give feedback, and of course approve and finally merge the changes using the pull request. So creating a pull request is quite easily done using GitHub. So obviously first you have to write code, commit and push, which we have learned today. And after that, you can go to your repository on GitHub, and you should see this green compare and pull request button. So when you click on the button, you'll be prompted for a title and a body for your pull request. So both of these should describe the changes that that are included. So for example, important dependency updates, and more detailed will be update field to a specific version. So these two fields allow the project owner to know why your pull request should be merged. So once you've done that, you have your very own pull request. So now it's your turn. The final mission today will be to create a pull request to merge everything you've created into the main repository. And the best pull request will be merged into the main repository. So let's just go back a bit. So if you go to your Git repository on your GitHub repository, you should see this compare and pull request button. If you don't, then let me know in the workshop help channel. Send a screenshot of the page. Okay, so I've seen most of your pull requests. It's all quite interesting, and it seems like uh, this is like the easiest part. So let's move on to the next section. So so today we've just had a small taste of what real open source is like, and it's actually pretty similar. It's all based on fork and pull requests. So to practice the skills that we've learned today, you can actually contribute to a real open source project. And you can find one by going to codetriage.com, and you can actually filter by the language that you like. And you can actually contribute to this real open source projects. And also another way, you can participate in open source events and competitions like the Hacktoberfest, which is organized by DigitalOcean, and the Google Code In. So they're actually really useful mentors that can help you with your open source journey. And of course, you get free shirts if you participate in these events. And you can even win the grand prize trip to Google if you win the Google Code In. So actually contributing to open source is one of the ways to gain real software development experience, and it really improves your communication skills. And last but not least, you can help out an open source project that will definitely appreciate the effort that you put in helping them. So to recap, here's the whole process, which is finding a project, forking, cloning, writing code, and of course pull request and merging of the pull request in the end. So it may seem quite complicated, but we've broken each step down into really small steps. So each step is quite easy. And we've actually come to the end of the workshop today. if you forgot any of the Git commands that we've learned, you can look at the cheat sheet, which is at bit.ly/bbcs20 git cheat. And oh yeah, we actually, if you realize today we've done all our development in Gitpod, and if you want to install Git to your computer, you can actually follow this guide here, which is at bit.ly/bbcs20 git dash download. And if you need any help with the installation or the subsequent usage, you can ping any organizer or any of the presenters today for help with your installation. And of course, these slides are available at this link. But we've also sent the full link to the chat, and I think Kenneth has pinned it for you. Okay, so thank you, and we hope that we've all learned something useful today, and we hope that you can harness the full power of Git and GitHub to assist you in your future software development. So thank you for attending our workshop today. It's been great.